Hi everybody, Mrs. Kroll here. This is going to be a video going through initial conditions and then how can we use those to find what's going to be called our particular solution. So it's going to say the first part, find the antiderivative. That's going to be our normal, just what we were working on. What's new is that it's going to be passing through the point 2, 4. And this value is going to be what's called our initial condition. Okay. So we're going to use that then to help us what's going to be called finding our particular solution. So let's go ahead and let's just find our general solution. So I'm going to find this antiderivative. So 3x, now remember we're going to add 1 to the exponent, 3x cubed divided by that exponent, so divide by 3, minus, okay, a constant we're just going to add an x to, and then we have to remember the plus c in the general solution. So I'm going to simplify this down, 3's cancel, so I'm like x cubed minus x plus c. And this is our general solution, because remember we talked about the c here, that c could be anything that we wanted to, because when we take the derivative, the c, the constant just falls off at the end. So we really have an infinite number of solutions here. C could be whatever number we want it to be. And that's where our initial condition comes in. So now we're going to use the point 2, 4 to help us solve for c, so that way then we have what's going to be called our particular solution. So it's just going to be for this one case that passes through 2, 4. So my y value is going to end up being 4. So I'm going to set my general solution equal to 4. And then wherever there's an x, I'm going to fill in 2. So 2 cubed minus 2 plus c. And then we're just going to solve. So 4 equals 2 cubed is going to end up being 8 minus 2 plus c. So 4 equals 6 plus c. So I'm going to subtract the 6 so that c is equal to -2. Now don't just leave it here. That's not actually the particular solution. We're going to take everything and fill it back in. So y equals x cubed minus x minus 2. And this answer right here would be our particular solution for this antiderivative that passes through the point 2, 4. Okay, so let's do one more. Why don't you try this one, pause the video, find the general solution, use the initial condition to help you then find the particular solution. Okay, starting off, general solution, I'm going to make it 8x to the 4th power divided by 4 plus 2x squared divided by 2 minus 5x plus c. Simplify this down, 2x to the 4th plus x squared minus 5x plus c. My initial condition is going to be 262. I'm going to use that and plug everything in then. Once I have everything plugged in, let's solve for c then. So 2 to the 4th power is 16 times 2 again is going to be 32 plus 4 minus 10 plus c. So 32 plus 4 minus 10 is going to give me 26 plus c. So 62 minus 26, c is 36. So my particular solution is going to be y equals 2x to the 4th plus x squared minus 5x plus 36. All right, so fairly straightforward when you're solving those, but then that helps us go into a couple of other pieces. So we can use that to help us as we start to solve other equations using those initial conditions. So a ball is thrown upwards from a height of 6 feet with an initial velocity of 60 feet per second. How high would the ball go? We're going to use the acceleration of negative 32 feet per second squared. So let's think about this. If I'm going to ask about how high will the ball go, that's looking at its max. Okay? And we know we can get max from the first derivative. Being equal to 0. That's how we find those maximum points. So I know I need the first derivative. Well, the first derivative would be the velocity equation in this part. And I'm given the acceleration. Okay, so I'm going to want to use this acceleration to help me find my velocity. I'm going to go with antiderivative to move back to the velocity equation. So up at the top, I'm going to use and write out all three because eventually we're going to end up using the other one too. So here's my acceleration formula or equation. Okay. Then my velocity, all right, well, that's going to end up being the antiderivative of this, so negative 32t plus c. Well, I know it starts off with an initial velocity of 60 feet per second. So that means at time 0, my velocity is going to be 60. So the whole thing is equal to 60 when I plug in 0 for t. Well, this one's nice and easy to solve. That cancels, so c is just going to be 60. So my velocity equation is going to be negative 32t plus 60. And then just because I know I'm going to end up using it eventually, let's also find the position function. Well, this is the first derivative, this is the second derivative. So if I use my first derivative, let's find its antiderivative to get back to the position function. Okay? So my position function, all right, this is going to be negative 32t squared over 2 plus 60t plus our c value. Where is it going to start from? Well, let's try and find our initial condition here. It has a height of 6 feet right away. So I know when I plug in 0, my y value is c is 6. So when I solve for this, all right, I'm going to have 0 plus c, so c is equal to 6. So my position function, and I'm going to simplify, negative 32 divided by 2 is negative 16t squared plus 60t plus 6. All right, so let's use these antiderivatives then to help me find out, all right, the answer to this question. How high will the ball go? So I want the maximum. So I'm going to set my first derivative equal to 0. So 0 equals negative 32t plus 60. Okay, and subtract the 60. And divide negative 60 by a negative 32. Gives me a time of 1.875 seconds. All right, so I know I have a max at that spot. But it doesn't ask me when will the ball hit a max height. It asks me how high will the ball go. So I actually want the position of it. So I'm going to take this t and I am going to plug it into the position function that I found before, and I'm going to take 1.875 and plug it in up here. So negative 16 times 1.875 squared plus 60 times 1.875 plus 6 gives me an answer of 62.25 feet. All right, next question to go along with this is what time will the ball hit the ground? So hitting the ground would be a position of 0. So I'm going to set my position function equal to 0. Now you can try and factor this if you want to. I'm going to use my quad formula on my calculator. You can do that, or remember, you can graph it too and see where it crosses the x-axis to get those other pieces. It does not factor nicely because I am going to have two answers for t. The first one is negative 0.097, and then the other one is 3.847 seconds. Now there's two answers there. The negative one does not make sense, so the ball will hit the ground at 3.847 seconds. Awesome. One more type of problem that goes along with this. It kind of is taking everything and applying it going forward. So this one, though, it wants you to find out what is the initial velocity of an object that's being, from ground level, being thrown up to reach the top of the Washington Monument, which is going to be 550 feet. So we're going to be solving for the initial velocity. I know a couple different things here. I'm going to use the acceleration of negative 32 feet per second squared again. Oops. Change this. So then I can go ahead and I can find my velocity. Well, that's going to be negative 32t plus c. And this c right here is going to be that initial velocity that we're trying to find. So I'm going to be solving this equation for c here, because if I plugged in 0 for time, that leftover part was going to be my initial velocity. So that's what I'm looking for. So I'm going to actually find the antiderivative with the c in there because I don't know what it is. So then my position function is going to be negative 32t squared over 2. So I'm going to just simplify right away. Negative 16t squared plus c times t plus my initial starting point. Well, where are we starting it from? Where's the object being thrown from? It's being thrown from ground level. So this is saying that we're starting on the ground, so at 0, 0. So if I would put on another piece here, I didn't really want to use c again because that's what I'm solving for. But if I'd put on another piece, it's going to end up being 0 anyways because the starting point is 0. So I'm solving for c. I want to find what c is equal to. Okay. Well, there's a couple things that are going to help us here, and that 550 is the next part, all right? So 550 is going to end up being my maximum. That's where I would like this to hit, right? That's my max point. Well, I know if that's my max, then I am going to have my velocity set equal to 0, and my position set equal to 550. And now I have two equations and two variables. Since I'm trying to get the maximum, the velocity we set equal to 0. And at that same time, I want that maximum to be 550 feet. So two equations, two variables. You can solve it however you want to. I think the easiest way, personally, would be to end up using substitution. So I'm going to set c equal to add over the 32t and I'm going to fill this in here for c because there's only one of them. Otherwise, I could solve for t and then plug it in and then solve for c that way, but then I'm plugging it into more spots. So for me, I think it's easier if I just solve for t by plugging 32t in for c here. So I'm going to do that. I'm just going to draw what I'm doing here. All right, so 550 equals negative 16t squared plus 32t times t. So 550 equals negative 16t squared plus 32t squared. So 550 equals negative 16 plus 32 is going to be 16t squared. So 550 divided by 16 is going to give me 34.375 t squared. And then I'm going to take the square root. Now remember, whenever we take the square root, it's always plus or minus, but it doesn't make sense to have that negative time. So I'm just going to go with the positive value of 5.863. Now this is my time. This is in seconds. It's asking you for the initial velocity, wanting what that c is. This is the time that it would hit that max point, but what's the initial velocity to get it to that 550? So I'm going to go back up to this equation right here. I know 32 times my time is going to be equal to c. So take that number and multiply by 32 to get 187.617. And now this is a velocity, so feet per second. If you have any questions at all with these couple problems and application problems, please let us know. We'd be happy to help you out.